This is a Monday recording of some problems we did in class, and I just wanted to get them on the internet for the kids that missed them, and some of the kids that did see them, I want to hear them again for possible requiz. I'll start with number 16. Number 16 was trying to decide which of these methods gave the bigger answer. If you take e to the x and you do a derivative on it and then a derivative on the derivative, you see the second derivative is e to the minus x. Since x is always positive, e to the minus x, or 1 over e, will always be positive. That means you should sketch this graph concave up. And the first derivative, because of this minus, is always negative. That means you should sketch this graph curving downward, because the slope will always be negative. Then with that in mind, you got to consider the LRAM and RRAMs. Remember, if you take these strips and figure out their heights off the left edges, if it's going downhill like this, the LRAM is always going to be high. And if you figure each of these strips' heights using the right edge to decide the height of the strips for approximation, you're going to be low for one that's going downhill to the right. TRAM, or trapezoid, is the average of these two. TRAM really takes a straight line between these points, and that gets very close to actual. So TRAM will be closest of the three. But since it's concave up, a trapezoid will go just above the curve at each connection, and even though it's the closest, it will be a little high. A, of course, stands for the perfect answer by integral, so you should rate them this way. R will be the lowest, LRAM will be the highest, and TRAM will be in between, just slightly above actual. Number 17. Number 17 asks how many vertical tangents you can make to the graph of y squared equals x minus x cubed. Tangents are made at the same slant as the slope. So I've done the first derivative of the original implicitly. So y squared turns to that, derived on y, and the right side turns to that, derived on x. If you want to isolate the slope, it means the slope is always this. And they're asking about vertical tangents, so they're really asking, when will the slope be straight up and down or infinite? Well, that would be when the bottom is 0, or better yet, when y is 0. So looking at how y relates to x in the original equation, when will y be 0? Well, y squared and y will both be 0 when this right side is 0. So we're really looking at, when will x times 1 minus x squared be 0? That factors easily. There's 3 places that will happen at 0, 1, and negative 1. So this should have 3 vertical tangents. Number 20. That was this one, and they were asking about the average value of this function. Average value would be average height. And even though there's a missing value there, we do have a value or height for every x, so we can calculate an area under the curve. That's easily doable in two sections. This right section is 4 by 7 or 28, and this left section is 33. It seemed like there was some call for reviewing trapezoid areas, so we kind of repeated this in class. This is the formula for area of a trapezoid: base plus base over 2, or average base, times how far the bases are apart. In this one, that's 8 and 3 for the bases, and they're 6 apart. So you had to figure out 8 plus 3 divided by 2 times 6. Without a calculator, you could cancel your 6 and 2 and make that just 11 times 3 if you're clever. Anyway, the area total appears to be 61. That's not the average height, because the width of this is 10. If the area is 61 and the width is 10, the average height has to be 6.1. I believe that was choice B. Then we worked on 22. 22 was requested in class. In that one, they gave the curve x cubed plus, oops, looking at the wrong one. In that one, they gave this little table that shows the values of the second derivative. And the thing to notice there is that it switches from negative to positive. The second derivative switches from negative to positive. That means it switches from concave down to concave up. In a sketch, switching from concave down to concave up would look like this. That's classic y equals x cubed type shape. The choices were linear, that wouldn't even be a curve. This couldn't have any concavity then. A quadratic wouldn't switch, it's always concave up or concave down. There's no switch. Cubic, I believe, is the choice here. A fourth degree function could switch one more time, but that would end up both tails going up or both tails going down. You can't have one tail down and one tail up with an even powered function. And an exponential function doesn't switch either. Another way of looking at it here, if you look real close at these numbers, they go up by 3s. So that's saying the slope of the second derivative, if graphed, would be 3. And since it's negative 1 at 0, you could come up with this equation for the second derivative. So the first derivative, backing up then, would have to be 3/2 x squared minus x plus some constant. And the original would have to be some power of x cubed. We really don't need to, for this question, figure out all this other stuff. We just need to know that it goes from power 1 to 3. 3 is cubic. So a couple ways to look at that. 23. 23 started with this equation, and they wanted you to use a tangent estimate to find the value of it at 3.1. Tangent is like finding the slope. Tangent goes at the same angle as a slope. So we have to do a derivative. So here's an implicitly done derivative. Notice We have to use the product rule right here because there's an x and a tangent y in the same term. So this will be the front times the derivative of the back plus the derivative of the front times the back. And then if you divide through by d of x so that it's written with just dy over dx isolated, you can see it written that way. Now, they're asking about this at the point 3, 0. So that means they want to know about this when x is 3 and y is 0. So you just put in 3's for x's and y's for 0's. And if you can remember just a little bit about your unit circle, you can figure all these out without any calculator and come up with the slope having to be -9. What that means is this graph comes through that point 3, 0 that they give you. It comes through that point at a slope of -9. That means down steep to the right. And they're asking you to estimate how high it is at when x is 3.1, just a tenth further to the right. Well, just that little far, it should be going pretty straight, so it'd be, you just treat it like a straight line for that little distance. And you can do a y equals mx plus b thing with this, but I think it's easier just to say if it goes 1/10 right and it's going down 9 times as fast as it's going over, it should be easy to see that this has to be -0.9. That is, from 3, 0 it went 1/10 right, 9/10 down. That would be a slope of -9. Moving on to 26, which we also did in class. That one was pretty easy. They said that this is discontinuous, and of course x could not be equal to 1. Notice that it's factorable, easily factorable. It's really the same as the graph of x. So if you graphed this on your calculator, it would have looked like this. You would just see a straight line. You would not notice a missing spot at x equals 1. But if you tried to put 1 into the table or something, you would get an error. There's an infinitely small missing spot because you can't have a 0 on the bottom there. So if you want to make this continuous, you have to throw in a point, and basically they're asking for it to be continuous, what is missing, and it would be that the f of 1 has to be 1. This one was pretty simple to see on the sketch. If you had another one reduced out and it wasn't x like that, you just have to take the 1 and substitute it into the equivalent equation to find the y that would make it continuous. For this one, the y that would make it continuous happens to match the x. 1, 1, the point 1, 1. 27, they're asking for inflections on the graph of 3x to the 5 minus 10x cubed. Well, did the first derivative, did the second derivative, pretty easy to factor, and inflections are places where the concavity switches from positive to negative or vice versa. So in other words, the double derivative would have to hit 0 for an inflection. Looks like it hits it at x of 0, -1, and 1. So I sketched this little graph, and knowing it had to hit here and here in here. That's not the graph of the original, but the graph of the second derivative. Second derivative has to start out negative, because if x was to the left of -1, you would have negative times negative times negative. Here it switches to just 2 negatives, or positive, 1 negative, and all positives. So that's 3 switches of sign in concavity. Each of those corresponds to an inflection point. So you're going to want to answer 3 inflections here. And finally, kind of a hard problem that we did, 28. They say f of x is equal to the integral from 0 to x of a function in t. If you could do that integral by hand, you would do the antiderivative of this. Well, we can't do that. It's too difficult. But I'll just imagine some function here I'll call t that is the antiderivative of this. So we're going to pretend you could do it, and it would be some function t that you would put in x, you'd put x into. Remember, this integral also corresponds to an area. Say if you graphed 4 minus t over t squared plus 2 from 0 to x, that area is also what we're talking about. As 0 increases to x, you could think of it like a wiper blade coming across here, gradually adding to the total area. So it starts out with no area, and by the time here, you've swiped out some area. The question wants to know, the question speaks of increasing and decreasing of this, so we have to do a derivative. Well, that's kind of fortunate actually, because the derivative will be the derivative of the thing that we couldn't find because it was too difficult. So, but it will go back to what we had. The only thing is x will have been subbed in. So this just turns to this. So now we have 4 plus x over x squared plus t. We couldn't do the antiderivative, but really didn't have to because we're coming back with a derivative, with the first derivative of the antiderivative. Kind of gets you to back where you started. It's just that x's have been put in for t. So now they're asking you about increase and decrease, so we have to decide when this slope is 0 and when it's positive and when it's negative. The bottom is always positive on this, so this is going to be positive when the top is positive, 0 when the top is 0, negative when the top is 0. So we're just looking at 4 plus x. And when x is -4, the slope will be 0. When x is to the left of that, or negativer, the slope will be negative, and to the right it'll be positive. So it looks like there will be a minimum, because slope switching from negative to positive says a minimum. So I'm recommending here choice C. That's a nutshell of what APCalc class did on Monday the 25th. Over and out.